everyone. I'm Trevor Blackmer with Epic Aircraft, and here at EAA Air Venture 2024. Standing in front of a brand new E1000 GX, and we're going to give you a walk around. So we'll start here at the left wing and we'll work our way all the way around to the cabin door. The basics of this airplane is it is all carbon fiber construction. Fuselage, wing, flight control surfaces, everything's carbon fiber. The only structural metal on this airplane is the landing gear and the engine mount. And we'll take a look at the gear in a minute. But otherwise, you can see the nice clean lines. We've got an elliptical leading edge to the wing. You can take a look at the cross section of the wing. You'll see kind of that critical airfoil shape scoop on the bottom of it. So does a nice job of producing a lot of lift, but a very little amount of drag. It's got dual everything, so everything is duplicated on the left side and on the right side. We have a pitot tube out at this end. Provides airspeed data for the pilot's PFD. We'll see one on the other wing for the co-pilot's PFD. So we work our way down the wing. We've got a AOA sensor, so this actually gives us angle of attack input. It's not just a stall warning vane, but it actually floats in the airflow to determine angle of attack. So we get an AOA indication on a gauge. It's also what activates our stall warning system. So this aircraft has a stick shaker to simulate stall and a stick pusher to help you recover from the stall before it actually aerodynamically stalls. You'll see a heating plate around here. This is part of the de-ice system. Behind the boot, that keeps it nice and warm so no ice can form around that AOA vane. We've got a vortex generating little wedges here. If you look at the top of the wing, we have another set of vortex generators in front of the aileron that help energize that airflow. During slow speed operations, keep the ailerons very effective. As we move down the wing, the next two wedges, these are induced stall at that location. So stall vanes there that cause the stall to originate at the wing root, not out at the tips. If we drop down, we're going to see we have a temperature probe. That drives the temperature indication on the pilot's PFD. And right next to it is an ice detector, which as it collects ice, it's looking at the refraction of light at the bottom of that probe, and will turn on an annunciator in the cockpit indicating we have icing. It's sort of a reminder to the pilot, if he isn't already noticing it on the windshield or in some other location, to turn on the de-ice systems of the aircraft. We'll take a look at the main landing gear, which is quite frankly a piece of artwork. This is all machined aluminum, solid, extremely robust trailing link gear. If you look at the actuator, it's a very clean well. That actuator has the down lock internal to it. It has an emergency nitrogen blowdown system that's also internal to it. And even the wiring for that is internal to the actuator. So it keeps the wheel well very free and clear so that there's nothing to get damaged by any debris that might get kicked up from a tire. Nice big brakes, although with a turboprop we usually use the propeller to slow and stop the airplane. It does have the big brake, so it can haul this thing to a stop in about 900 feet from the time the tires touch the ground. As we move forward, we have a ground power port here to have 28 volts added to the aircraft. With that, we can run ground power for avionics. We can also run the air conditioner to pre-cool the cabin. Above the ground power port, we've got an exit for our inertial separator. You can look in there and you can see some raw carbon fiber. That's the exit point for heavy particles, essentially that enter the inlet of the engine. From a de-icing perspective, we keep ice out of the intake of the engine, or the actual compressor blades of the engine by allowing those heavier particles to just flow through, inertially separating from the airflow. Above this is a nice light, so this lights up both the leading edge and the top of the wing for looking at night to see whether or not there's ice on the wing. Above that is a intake for air-to-air heat exchanger, which cools the bleed air that's coming off from the engine. It goes into the cabin. Of course, you'll see an exhaust stack. This is a Frakes exhaust stack, custom for the Epic. It does a great job of keeping exhaust sooting off from the actual fuselage. As we move around to the front of the airplane, we'll look at the propeller. It's a 5-bladed Hartzell composite propeller, almost 9 feet in diameter. And since this aircraft was designed around the 1200 horsepower PT6 A-67A engine, it has long legs, so we could put a big prop that turns at a relatively low RPM of just 1700 for takeoff and as low as 1500 for cruise. This is kind of a cool look of the intake of the engine. Again, you'll see some nice raw carbon fiber. It splits the airflow into a left and a right. That's then directed back to the plenum that goes around the engine intake or out the two inertial separator vanes. Dropping down in front, we can see the nose gear, another really robust piece of machined aluminum. It has integrated LED taxi lights, and kind of a unique feature is that it has a breakout nose wheel that allows you to caster beyond what you can steer. So that aluminum structure you see there with the two hooks on the end is what limits the turn degree of the nose wheel when it's in that caster mode. So because we have so much horsepower, we need a steerable nose wheel to manage torque during takeoff, but we also have the advantage of a castering nose wheel with this system for making tight turns on small ramps, maybe maneuvering around in front of your hangar, that sort of thing. You can check the pins below that, kind of a standard towing pin, and that 60-degree roughly turning radius of the tire is the turning radius or the maximum limit for towing as well. As we look at the right-hand side of the cowl, it is nearly identical to the left with the exception of no power port. The nose gear doors there, if you want to take a look up in the actual nose gear well, you'll see some of the mechanism of that turning device and the breakout nose wheel function. You'll see some springs and some little arms up there. Only because I'll bang my head, I won't get up there in the middle of this. As we move into the right wing, in the right wheel well, if we look right up this direction, we'll see a round hole. And in that hole, you'll see a round disc of red fluid, and that's our hydraulic check, so we can check our hydraulic fluid level. The only system that operates off from the engine-driven hydraulic pump is the landing gear. It's a 3,000 PSI system. As you may have heard me mention before, it does have a nitrogen blow-down backup to that hydraulic system. Each wing holds 132 gallons of fuel. It gives the aircraft roughly 5 hours of fuel at high-speed cruise, so figure you can do a 4-hour leg at greater than 300 knots. It results in about a 1,200-mile range. If you slow it down a little bit, we can stretch that range out to about 5 hours worth of time and about 1,500 miles.
Talk about the boots.
Okay. So the de-ice systems on the aircraft, we already talked about the inertial separator. On the wings and on the horizontal stab are pneumatic boots. Those will inflate to break ice off. Once they're turned on, they're an automatic system. So every 60 seconds, they'll cycle to the inflated mode for 6 seconds and then deflate for 54 seconds and keep repeating that automatically. Again, we have that ice detector light. When that comes on, we know to turn on the de-ice systems. Although we didn't mention it on the propeller, it's electrically de-iced. So the roots of the blades have electric heating mats that keep that area clear of ice, and basically just inertial force will keep the rest of the blade clear of ice. Also, as we mentioned, stall warning vanes, pitot tubes are electrically heated. If you kind of look up on top of the cowl and on top of the pilot's side windshield, you'll see a little cuff there, and that is pneumatic bleed air off from the engine that de-ices the pilot's side windshield. So it comes off from the same bleed air that would pressurize the cabin. Within each wingtip, you'll see a light pack, and this is our landing lights, our strobe lights. It's all behind the lens to keep it nice and slippery from an aerodynamic perspective. We were talking about fuel. All the fuel is in a wet wing cell, so between the front main spar and the rear spar, between the wingtip and the landing gear door is all fuel tank. And it's baffled. It has a full-length capacitance probe sender, which gives a nice accurate fuel gauge reading on the fuel gauges inside. When we get inside, we'll look at that, but basically that measurement is taken automatically and displayed on the Garmin system. You can just synchronize your fuel when you get on board the aircraft, and it measures it for you. Ailerons, as we mentioned, are composite. Everything about this airplane is nice and smooth and precise. The flight control cables actually run down the leading edge behind our de-ice boots, a push rod that moves the aileron. Our flaps are also a fairly simple system. We'll go ahead and show you later what they look like deployed, but they are a double slotted cuffed Fowler flap. They run just off from a torque tube and push rods. So there's a single electric motor turning a torque tube. Keeps, again, that system really simple and robust. No possibility of a split flap, which is an advantage. On this side, you'll see emergency exit. It's a fairly large exit. It's an easy door to operate from an external. If you had rescue personnel or somebody trying to get into the aircraft to help somebody out of that door, it's easy to do. As some of you may know, Epic and this model started as a kit plane in 2005, and so for about 10 years that product was produced, and so it was a factory built but owner assist type of kit plane. And one of the ways you can tell the difference between a kit plane and a certified airplane is the certified airplane has an emergency exit. Back here you'll notice static port, fairly standard. It has ports for pilot side and co-pilot side, and also reference for the pressurization system. This inlet here goes into the air conditioning heat exchanger. So in the empennage there is a electrically powered vapor cycle air conditioner. You can run it on the ground with ground power, as we mentioned before. Otherwise, it augments the cooling system of the air-to-air heat exchangers that cool the bleed air in the airplane. Horizontal stabilizer, pretty standard device. The elevator will check its travel. Again, all carbon fiber, very free moving controls. They don't require any counterweights, plumb bobs, other things that you often find in some legacy aircraft products. And something that's a little bit unique to the Epic that I've noticed, coming from a whole different background of flying a lot of different airplanes, is that it's the only airplane I've ever flown that's in takeoff trim with takeoff flaps. It's in takeoff trim when it's in cruise and no flaps, and it's at takeoff trim when you're landing at landing ref with landing flaps. Which means that this trim tab is nearly always in line with the elevator, and that elevator is nearly always in line with the horizontal stabilizer, which makes for a very efficient aircraft. You'll notice here too, we've got dual actuators from the trim motors. The trim motor is internal to that flight control, so it's a trim by wire system. There are no physical cables to any of the trim tabs on the aircraft. You'll also notice a fairly large trim tab up here on the rudder. This one is actually set right now for takeoff. You'll see that that would then be helping you push right rudder as a pilot for takeoff. And in normal cruise, that would be relatively centered as well. This is the exit for that same air conditioning heat exchanger that we looked at the inlet for on the other side. And finally, we're back to the main cabin entry door, which we'll go ahead and open. Let's open it, push here, rotate, stow that handle, and just step out of the way. All right. So, welcome to the inside of the Epic. This is the largest cabin of any 6-seat single-engine turboprop, of which there are a couple. Has a nice flat floor. You'll notice a lot of distance, a lot of space between the seats in the club. Nice wide aisleway for pilots to get in and out of the cockpit. The baggage space is behind these seats. You can access that by folding the seats down. And in here, it's hard to have scale, but essentially 7 rollerboard bags will fit here. You can also stand a set of golf clubs up. Actually, 2 sets of golf clubs up. So each seat in the Epic is the same size. A lot of times the rear seats of this configuration of aircraft are smaller. The Epic has full-size seats in the rear, so you can get 6 full-size adults in this airplane. It's also fairly unique in that it's essentially a full seats, full tanks airplane. So it has 1,100 pounds of payload at its full fuel empty weight, if you will. So in this environment, each passenger has some USB charging ports. You can see down here, USB-A, USB-C, a powered headset jack. You'll notice a crew call button, which is kind of unique. That's so when the cabin is isolated on the intercom, there's a way to get in touch with the pilot who may not see or hear what's going on in the back. It lights up a little annunciation in what's called the wedge panel. We'll show you that in a little bit. You have cup holders at each location, you know, kind of standard stuff. Place for cell phones, pockets on the side, maybe for an iPad, a laptop computer. Between the seats, there's also quite a lot of space. I'll kind of give you a quick view of that by folding this down, but space for things like cooler, flight bags, additional suitcases. You'll notice these windows are a little bit unique in that you'll see they're kind of tinted. They're electrochromically darkened or lightened, so they're powered clear, and when they lose power they get dark. And I'll show you that here in a little bit too. Each person has an air vent, a light at their seat location. At night, it's kind of a neat cabin in that we've got this indirect lighting which can be dimmed. It's on a rheostat in the cockpit that the pilot controls. We've got some neat accent lighting that lights up as well. So it's a really pretty cabin, it's a really spacious cabin, comfortable place to spend 4 hours and, you know, move halfway across the country in that time. We can go up front. The Epic has a very ergonomic and pilot focused cockpit in that it's easy to fly, easy to run through flows and checklists and not miss anything. And part of that is due to the fact that everything happens in order. So if you look at these buttons, starting with battery 1, you'll see how it's labeled pre-start. Pushing these buttons in order left to right starts the airplane. After start, the second row of buttons left to right turns on all the systems in the airplane. If we extend that second row to the right of the yoke, turn our taxi light on for taxi, come over and set our flaps for takeoff, maybe turn the air conditioning on, and at that point we would push our propeller and condition lever forward and the airplane would start to move. Get out to the runway, we'll add 2 more buttons to the list, the pitot heat and the landing lights, and we're off to the races, so to speak. That's as complicated as this gets. So with all of that, it makes it, again, an easy airplane for pilots to manage, and it makes it really obvious when you've maybe skipped something. That said, we'll go ahead and turn on our batteries to light this all up. Kind of a neat feature while it is booting up that the Epic has is this adjustable glare shield. So we can pull this out. Creates a little more shade in the cockpit when it's sunny. It also creates shade on the windscreens at night, so you don't get any glare off from any of the lighting on the flight displays or sub panels reflecting off in the windshield. As we mentioned, a fuel on board sync will quickly totalize the fuel on board. So we like to bring these aircraft in light to Oshkosh so that we can roll them onto the grass with no problems. Once we've synchronized our fuel on board, we can bring up a flight plan view. This is where we could either program the flight plan manually, or what's really more common now is grabbing your phone, opening up ForeFlight, and just wirelessly sending your flight plan to the displays. You could have hundreds of waypoints, they'll all be loaded instantly, you can acknowledge it and move on. On the main map display, the GPS has found our location. It's enabled the synthetic vision on the PFDs. Obviously we can see ourselves on the safe taxi here at Oshkosh. General layout of what we're seeing here. Torque, in case you aren't familiar with that, basically that is like the horsepower of the engine. So it's displayed as a percentage of the total 1200 we have available for takeoff. So 100% would be 1200 horsepower. 83%, or 83 1/3, which is this little white line, would be 1000 horsepower, which is our max continuous horsepower when flying. ITT, or interturbine temperature, is the heat within the engine. Our NP is the velocity of our propeller, our RPM. NG is the velocity of our gas generator, or the N2 sometimes it's called, but the fast spinning turbine that's generating the power and the heat. Oil pressure and temperature are fairly self-explanatory. The generator is a 300 amp generator. Load is displayed there. The alternator, which is sort of an alternate power source or an auxiliary power source, is rated for 41 amps. If it is on, the load will be displayed there. And then it has 2 ship batteries, and we're seeing voltage on those batteries on that next gauge. Coming right across next to it, we have the position of our elevator trim, rudder trim, aileron trim. You can see the rudder trim is set about half scale to the right, which would be normal for takeoff. Flaps are currently indicated up. We have a cabin rate of climb or descent, a differential pressure, which this aircraft goes to 6.6 PSID, or pounds per square inch of differential. Oxygen pressure is the pressure of the the emergency auction, which is available to the pilots really anytime. The passengers, it's available to through drop-down masks that fall automatically from the ceiling if it senses depressurization. Nitrogen pressure is that system that we talked about for the landing gear emergency extension. Fuel pressure and fuel flow based on essentially the pump pressure that's being generated by electric fuel pumps in the tank, and the fuel flow is what the engine is consuming. A lot of, we won't go into the G1000 and everything it does, but essentially it's typical G1000 NXI as far as what it's capable of displaying. It's a great system to be in this aircraft. This is often a person's first turbine aircraft, and probably the most common set of avionics that anybody is coming out of in the piston flying world is a G1000 NXI, whether that's from a Cirrus or maybe a Bonanza or a Baron, and of course numerous other aircraft. Some of the controls for the engine that we already talked about were we have a propeller control and what's called a condition lever. Essentially that sets the idle speed of the engine. So on the ground we can run at a higher idle or a lower idle. What that does is it helps set propeller RPM. So the high idle keeps the propeller RPM essentially greater than 900, which is the top of this little yellow arc. Or when we're back in the feathered position in that low idle, it keeps it below 400 RPM, which is the bottom of that yellow arc. And that yellow arc is just a transient zone that we don't run for extended periods of time. You can set up a certain resonance with a composite propeller if it's run in that zone. As we mentioned, our flaps are electric. We'll go ahead and set our flaps for landing so that when we go outside of the aircraft, I can show you what they look like. But we have a takeoff position. We'll notice right in front of us here, we have flaps in transition indication, and then now they're in takeoff. That's repeated down here on the Garmin multifunction display. We'll set them now to full, which will take a little longer. So again, we're going to get a transition here, and eventually they'll get down to the full 43 degrees of deflection and show full. And there they are. As we mentioned outside the aircraft, the trim is all trim by wire. On the primary trim controller, we have pitch trim, which is nose down, nose up. We also have yaw trim, left and right. It's a two-part switch, so we have to push down on this top hat to activate the system and then move it the direction we want it to go. If we look over here, we'll now see the trim is moving nose down. And obviously the opposite, nose up. We'll set it for takeoff once again. On the other side here, we have aileron trim or roll trim. Generally that is only used for possibly a fuel imbalance situation. So we can see again trim position here, the aileron is neutral or set in the middle. Other switches on the control yoke is a trim interrupt and disconnect and autopilot disconnect, all in one switch. So this red button essentially deactivates every servo in the airplane, whether it's trim, autopilot, or the stick pusher system as well. Pressing and holding it deactivates everything. If we press and hold it for at least a second and a half, we'll actually get a trim disconnect. So if you had a runaway trim, you would press and hold it for a second and a half or more, and it has disconnected power to the trim system so that any runaway situation is corrected. If you're just checking the system like we did, we can press this trim reset and that goes away and our trim is active once again. Finally, you have a control wheel steering button, which is what it does in most aircraft. Essentially, it can interrupt the autopilot, allow you to hand fly freely for a moment. It also synchronizes things like indicated airspeed mode, vertical speed mode, or pitch mode. Kind of a neat feature in the Epic. We have a push to talk on the back of each yoke, but we also have a push to talk on the bottom of the armrest. So if you're receiving a call from air traffic control, you can leave your hand on the armrest. You can acknowledge that with the push to talk, as opposed to having to reach up and grab the yoke. Behind this panel are some non-frequently used switches. So there are test switches and reset switches. So we can do a stall warning test, which is our stick shaker and stick pusher. And then the prop gov test is basically to check our overspeed governor on the propeller system. The generator resets and trips and overvoltage tests are really not used as a normal part of day-to-day flying, but they are the way to control the generator's functions if necessary in those modes. So to show you quickly a stall test, or what a stick shaker looks like, that is a shaker. It is pushing forward. So essentially what you heard and saw there is how it signifies approaching a stall. The pusher actually commands the control forward with enough force that it will self-recover or essentially not allow the aircraft to stall, and the pilot would have to push that red button to overpower it or override it if for some reason the pilot felt that they didn't want the stick pusher activated. So we generally will check that prior to flight, just like Leo will check our autopilot prior to flight. Same kind of situation. You can turn on the autopilot, it locks up the controls. We can trim to release the yoke control. We can push the red button to release the yaw damper, the rudder control. So back into the cabin, as we powered down the airplane, you'll notice this lighting came on, which is really nice at night, because normally when you take all the power off the airplane, it goes dark. So this allows you to see to get to the door. You also see these step lights are kind of cool. To open the door, we just pull this T-handle, which essentially pulled that button in that we pushed outside that releases this handle. Once we've released that handle, we finish opening it, let the door fall. All right, as we've come outside, I'll let you take a quick look at this giant flap and the double slot and the cuff. It's pretty neat. I hope you all enjoyed our quick tour of the Epic E1000 GX, and we'll look forward to maybe getting you in the cockpit one day. Thanks a lot.